Welcome back, guys. Today we're going to go over 4-1 proportional relationships, and hopefully by the end of today you'll be able to identify linear relationships as a constant rate of change, determine if two quantities are proportional. So first off, we're going to have some definitions here. A ratio is a comparison of two values. A is to B, or A colon B, or A divided by B. Next we have a rate. A rate is a ratio that compares two quantities of different kinds of units. Rate of change, how quantities change in relation to others. Linear is just a line, and a linear relation when the rate of change is constant, meaning it's always the same. From here, we have two tables, and we're going to try to figure out if the relationship is linear. If so, find the constant rate of change. If not, explain. So this first one here, from 3 to 6, what's happening there for the number of transactions? And as you can see there, it looks like it's increasing by 3. And then what about from 6 to 9? It also looks like it's increasing by 3. So now we look at the balance, the number of dollars. So we go from 170 to 140, and we get a negative 30. 140 to 110 also looks like a negative 30. So from those transactions and the running balance, it looks like this is going to be linear because it has a constant rate of change. And to show that, I would show my balance, negative 30, divided by this value over here, which is 3, and then I get a negative 10 over 1. Now the second one, same thing, I check to find out from here what's happening, and it looks like it's increasing by 5. What about from 10 to 15? It is also increasing by 5. And before you think, oh, this is linear, we got to check over here to make sure that it is. And so 95 to 90 is a decrease of negative 5, and 90 to 82 is a decrease of 8. So from here, this one is not linear. The rate is not constant. Now looking at a graph, we can do the exact same thing. I need to figure out from this point to that point, how far did I go up and down and left and right? And then same thing over here. So I start out by figuring that out. How far down did I move? Well, the dot here is at 120. I went to 80, and I just do 120 minus 80 to give me 40, so negative 40. How far over did I move from here to that dot? I go down here, that's from 8 to 16, that looks like a positive 8. How far down again? And it looks like 40 more, so negative 40. How far over? 8 again. And so now I can start writing my stuff out. This one is linear. The reason I know it's linear is because I have negative 40 divided by 8, which gives me a negative 5 over 1, and it's constant. It's the same all the way across. The second one, it looks pretty interesting, but from there I just figure out I went down negative 500, so there's 4,000 to 2,000. That means that line's 3,000, and halfway in between there would be 3,500. And then moving over, it looks like I just moved 2. And then I go down 1,000, and I move over 4. And so that means my rate of change here would be a negative 1,000 divided by 4, and that would equal negative 500 divided by 2, which would equal negative 250 divided by 1. And these are all equal. They're the same value. So this one is linear. Even though it looks like there might be some differences, this is linear. It's going to make a straight line. Now, proportional linear relationships, they have two quantities that have a constant ratio and a constant rate of change. The rate of change is always the same. The graph must pass through the origin. So when doing problems like this, you need to do several things. The first one is to be proportional. You have to have a constant rate of change. And it looks like, so our constant rate of change. And second, you need to have equivalent ratios. And third, the graph needs to pass through the origin. And what that looks like is the dot, your line needs to go through this point where x and y meet. That's called the origin. So this is what you need to do on your assignment. You need to test 1, 2, and 3. So you find out the constant rate of change, equivalent ratios, and graph it. If all three of those things work, then it is a proportional linear relation. So using that information, we're going to determine if these tables or graphs are proportional relationships. So the first thing here is I need to figure out from there to there it increases by 5, and then from 5 to 10, and 15, and 20. So it's increasing by 5 every time. The Celsius, so Fahrenheit now, is increasing by 9 every single time. And as a result of that, number 1, the rate of change, 9 divided by 5. Step 2 are proportional relationships. I take this top value and I divide the bottom value. Top value divided by bottom value, top value divided by bottom value. And I noticed that 0 divided by 32 is not 5 divided by 41. That's 0, that's not. So those ones are not equal, and that means that this is linear and not proportional. This next one I notice, because it's not proportional, it's linear only, but now on here I have increasing by 1 every single time. Down below it looks like I'm increasing by 3 every single time. So now I have a 3 divided by 1, so I take this number divided by that number, and then I take 2, 1/3, 2/6, 3/9, and 4/12, and so forth. But I notice that 1/3 is equal to 2/6. It is equal to 3/9, and so I have proportional. And as a result of that, we're able to move on to our graphing part. Now looking at this one again, starting with this point, going to that point, how far up do I have to go, and how far over do I have to go? So it looks like we went up 40 and over 8, 40 more, 8 more. So number 1, I write down the relation, which is 40 divided by 8, which is 5 over 1. Step 2, I write my ratios, which are these points. So I take this point 8 and I divide it by 40. I take this point 16 and I divide it by 80, and I take this point right here, which is 24, and divide it by 120. And if those are all equal, then we should be okay, which they are. So this one is proportional, and if I notice here, the graph of this one does pass through the origin being right there. This next one, as we can see here, it moves from here to there, which is 1,000. It goes over 1. Then it'll go again, up 1 over 1. So same thing, 1,000 divided by 1. Step 2, I notice that the point there is going to be a 1 divided by 3,000, and then a 2 divided by 4,000, which those two are definitely not equal. So as a result of that, this one is not proportional. It is linear, it's just not proportional. Our last two things that we need to do for today, we need to graph this relationship and label the axis, then determine if the relationship is proportional or non-proportional. So this first one, I have 2 chocolates every day. So to figure that out, I need to figure out that I need chocolates and days, so I'm going to make a table. So I make a table with days and chocolates. On the first day I have 2 chocolates. On the second day I would have 4 chocolates total. On this third day 6 chocolates, and so forth. So I'm going to label this bottom axis days. And typically in graphing, the x-axis is typically time. So days is a type of time. And then the y-axis I'm going to label chocolates. And then from there I just have my ordered pairs. Now these ordered pairs, I go 1, 2, so I go over 1, up 2, over 2, up 4, over 3, up 6, and so forth. And so I notice here that the ratio is 2 divided by 1, and 1/2 equals 2/4 equals 3/6 is true, and this graph does pass through the origin. So as a result of this, this is a proportional relationship, and we are done with this problem. Our last problem, same type of thing. The graph or the table's already done for us, so we just need to label this, And so labeling this one, I would start out putting this one X, that one Y. So my X-axis here, I've labeled and I've skipped because I want some space here, and I noticed I had space to use. So this one up here I don't have as much space, so I'm going to label this one weight because I have it here as the X-axis. This one up here I use every single one, and I'm going to label that one mass. And then I just start graphing the ordered pairs, which is 20 zeros. So 20 zeros right there. I put a dot, 40, 18, and 60, 27, and 80, and 36. So as a result of that, I could kind of see from there, if I were to draw a line from this point to that point, it doesn't look like all the dots will pass through that line. So I know that this is not a constant rate of change, and as a result of that is not proportional. Good luck on your assignment. Hope you have a good day, and we'll talk to you later.